All right, for this next problem, we're supposed to be simplifying and giving the restrictions in the Your Turn problems of section 12.1. So the numerator, x squared plus 4, that's the sum of two perfect squares. The sum of two perfect squares cannot be factored. So we're not going to do anything to that. The denominator can be factored, so we're going to be factoring this. The factors of 14 that give us a difference of 5. Those would be 7 and 2, but this time we need a negative 7 and a positive 2, as opposed to the last time we saw that 14 and 5. And then from there, we can't do anything, so this one is actually simplified as much as possible. And finding its restrictions are based upon these two factors down here, so we set these equal to 0. X plus 2 is equal to 0, and we solve for this, getting that x is equal to a negative 2 here. And then we set x minus 7 equal to 0 as well. And we get that x is equal to a positive 7 in that particular case. And therefore, we have the two values that are restricted in the domain. So if we wanted to write that as a domain, we would say that the domain here would be all x's such that x wouldn't be equal to a negative 2 or a positive 7. So remember, even though you're solving for those values, you're solving for those values to eliminate them, to restrict them, to say they're not equal to in the domain. All right, for part B of number 1 in the Your Turn, we are looking at a numerator which has a negative leading coefficient. So the first thing I'm going to do is I'm going to factor out a negative 1. Now remember, factoring out a negative 1 changes all the signs. So this one is a negative, and now it's a positive. This one was a negative, and so now it's a positive. This next one was a negative, so now it's a positive. And then the denominator, I'll just be factoring. So factoring this, I have the factors of 2 that give me a difference of 1. So I have an x with a 2 and an x with a 1, and then I just need to make sure that my signs are right, so I get a negative 1, which means the 2, the bigger one, has to be negative, and the smaller one, the 1, has to be positive. And now the last thing that I want to do, don't forget the GCF of a negative 1 out here, is that I need to factor out the x squared plus 3x plus 2. So I need the factors of 2 that give me a sum of 3. So this time around I have an x with a 2 and an x with a 1, but they both need to be the same sign, and those signs are positive. And so now that I have it all factored out, now I can do the simplification, I can do the canceling part. And it turns out this time I have an x plus 1 canceling with an x plus 1. And that leaves me with a negative fraction of x plus 2 over an x minus 2. Now don't get too jumpy on this and say, oh, that means I could cancel the x's and I can cancel the 2's and I can get a 0, or I can get a 1 over a 1, or whatever the craziness that I see as far as answers go on this. It's none of those. It is exactly what you see in front of your face. And then, of course, on the restrictions, we have to look at the original denominator, right, not canceled ones, and we have to say, where would this denominator be equal to 0? So x minus 2 equals 0, and x plus 1 is equal to 0. Set those factors equal to 0 and solve. So adding 2 here and here, we get x is equal to a 2. And here we get a negative 1 and a negative 1, and we get x is equal to a negative 1. And so if we were going to write this as a domain, right, we would say the domain is all x's such that x doesn't equal a negative 1 or a positive 2. And that would be our domain on this particular instance. So there you see the simplification, and there you see the domain, the restrictions. All right, our second problem, we can't find any domains in the second problem because we have x's and y's. Now this one, 4 terms, remember, if there's no GCF all the way across, and I look across here, I have 2's and 3's, but I don't have anything in common all the way across. And the same thing here, therefore 4 terms, factoring by grouping. So here 2 and here 2. So in the first 2, I see that I have a 3x in common, so I'm going to take that 3x out, and that's going to leave me with a 2x, and then plus a 3y. Then in the second two, I see these are both negative, and I have two positives here. So I'm going to take out a negative, and I'm going to take out a y, which is going to leave me with a positive 2x. Remember, it was negative, so I took out a negative. It's now going to be a positive. And then again, plus, because it was negative, and I took out a negative, so now it's positive, 3y. And now, one more time, right, I have the binomial GCF that I'm looking at from this term and this term. And the binomial GCF this time around is going to be this 2x plus 3y that I see in each terms. Now, one of the biggest mistakes that I do see is seeing this 2x plus 3y quantity squared. That's not true. Remember, it is the GCF. The GCF always gets written out here, just GCF, right? And then what's left over from the first term, 3x in this case, minus what's left over in the second term, a y in this case. And we end up looking like a binomial times a binomial. Now let's go ahead and do the denominator on this one. Same thing, right? We're going to look at these two terms and these two terms. So from the first two, I'm going to take out a 2x. And that's going to leave me with an x and then minus 1. And then from these second two, I see that I have a 3y in common, so plus 3y. And from the first term, I'm going to be left with a 1. And then from the second term, I'm going to be left with a minus y. And that one is not going to get me anywhere, is it? So I see this here has nothing in common with that one there. So, what else might I be able to do with this? So let's see if some rearranging will help. So I'm going to go ahead and I'm going to erase all this. And if I were writing on a regular piece of paper, I would simply go ahead and I would cross it out and I'd start over again so I could see what I did. But because I'm not writing on a regular piece of paper, I'm not going to do it that way. But I'm going to change to black and I'm going to say, okay, well, let's try this one. 2x squared and 2x squared minus 3y squared, and then minus 2x and plus 3y. And then let's see what happens with that. So in grouping the first two, what I'm going to notice is I'm going to have nothing in common again that comes out in these, and then nothing that would come out in common in those. So that's not going to work either. So let's just flip-flop these first two terms and see what happens. And so we see that I have a negative, or 2x, and then plus a 3y, and then a minus 2x, and then a minus a 3y squared. So now I see that from here I can take nothing out in common, and then from here I can have nothing else in common. And so these actually don't factor at all. And so as I look at this one, I have 2x squared minus 2x plus, or minus actually, let's do minus 3y squared, and then plus 3y. And there, we're just going to take it and end it. Now, if this had been an x in this one right here, this would have factored somewhere, and we would have been able to factor it more. So maybe what I would like to do with this one is actually rewrite it in such a way so that we could see that. So if I had a 2x squared here minus a 2x, and then minus a 3xy squared, and then plus a 3y, look what would have happened. And I'm going to write this in green so it looks different than what's above. I would have taken a 2x out of the first two terms, and that would have left me with an x minus a 1. And then out of these two, I need a positive minus. So I'm going to take a negative, and I'm going to take a 3y out of those. Oops, it would have been, this one would have needed to be a y. So, sorry, make this one just a y. should have been an xy term instead of a y term, y squared. And if I take a 3y out of those, that would have left a positive x and a negative 1 there. And then that would have given me a 2x minus a 3y. And then I would have had left over, or the GCF, the x minus 1. And so that's one way that would have factored. So there could have been factoring had this been a second degree term, but the second degree term being an xy, not a y squared. So anyway, that's just one more factoring by grouping example. So anyway, as it was left, this is all we could have. Now this one, obviously we can't find a domain because this is not a polynomial expression, right? It is actually an algebraic expression over an algebraic expression. It has more than one variable. All right, moving on to example number 3 here. We're going to find f of negative 1 for y squared, for x squared plus 5 over x squared minus 5 minus 14. That's problem number 1. Remember, this is just evaluating. So this says f of negative 1 is substitute in negative 1 wherever we see the x. So there's our x squared plus 4 over, and then we have our x squared. So negative 1 squared minus 5 times negative 1 and then minus 14. So now we just are going to simplify. So negative 1 squared gives me a positive 1. Negative times a negative is a positive, and 1 times 1 is 1. So 1 plus 4 is 5. And then here we have 1 squared, which is 1, and then we have a negative 5 plus times a negative 1, which is a positive 5. So we have 1 plus 5, which is 6, and then 6 minus 14, which is a negative 8. And so we have our f of negative 1 is equal to negative 5/8. And so that would be our value. And that's just a quick brief review of evaluating. So this ends chapter 12.1 review.